We're 100%. Okay. So I've got the chat over in another window here, and I've got like one eye on that and one eye on the rest of the screen. I hear a few little people saying there's no noise. I see noise now. You didn't miss anything. The bit that I was saying, whilst we had that little glitch there, was that I just decided to fill out this talk title with as many words as I could fit in the 2 lines. And per the title here, I'm going to be talking a lot about Azure and particularly around the way I'm managing Have I Been Pwned, which we're going to talk about in a moment. And what I really want to touch on here is I want to get into things like talking about PaaS. I want to talk about the good things that I've found with PaaS and then where I've run into problems. So this is a warts and all talk. I want to talk a lot about functions. I'm moving a lot of stuff into functions these days, and I'm really, really genuinely excited about that. We're going to talk about why this is cool, particularly from scaling. We're going to talk about Goldilocks. That will make sense in a moment. Storage, and I'm also going to do a bit on Cloudflare as well, because that makes Azure extra awesome. So let me then jump into it. And I want to start by talking a little bit about Have I Been Pwned. Now, a bunch of you will probably be familiar with this service already. If you're not, then you can go to havebeenpwned.com, plug in your email address, and it will tell you if you are in any one of 307 data breaches which we have seen in the past. There was 307. I added 42 million more records last night, and that's actually blown things out a little bit further. So it has grown somewhat. It will tell you if your data has been leaked publicly. And it does this by when you plug in your email address, it goes through and searches a whole bunch of data stored in Azure table storage in the back end. Pulls it back super, super fast and comes back and tells you where you've been exposed. Now, I'm not going to sort of delve too much into that today because this is stuff that I've talked about for many, many years. I want to talk about some of the newer stuff. And I'm going to begin that by talking about scaling PaaS. Now, just to pause for a moment as well, if you guys have questions as we go along, please ask them because it makes it more interesting. Otherwise, I just sort of sit here and talk to myself for quite some time. So ask them, and Javier or Duke will either interrupt, or if I see them pop up in the Twitch window on the side, I'll try and answer them on the fly as well. So let's talk about, and incidentally, Cow Sniper, I can see your tweets. They're not tweets, are they? Are they Twitches? Messages. I've got a headset on now, so you shouldn't be getting any echo back. And what that means is that it sits on logical servers that run up in, I'm doing air quotes here, the cloud, which is super, super cool because it means I can have as much or as little cloud as I want. Now, one of the things I did really, really early on is I did a lot of work with autoscale. And I want to talk a little about autoscale, about how it worked really, really well, and then some of the challenges that I've run into and how that's led me down a different path. So this is what my autoscale on Azure looks like today. And the premise of autoscale is that you have a number of logical machines. If those logical machines become overburdened, you can add more logical machines automagically. And then when they've got too much resources, way more than you need for the traffic, you start to take them away. So for example, in my case here, I said, look, if my CPU gets above 45% on average across however many machines there are, give me another one. And then if we go the other way, if it starts to get too low, below 25%, take one away. And then I just like maxed out the maximum. I can have up to 10 of them, like just keep adding machines until my site actually runs like it should. Now, within these criteria, we can then go and get very, very specific. So for example, I've said, look, I want to try and scale up pretty aggressively because it means that there's going to be a bunch of traffic coming suddenly, and I want to be able to handle that. That's why my 45% threshold is reasonably low. You'll see I've got a duration of 5 minutes in there. And this is sort of the shortest duration you can have. And what I'm saying here is that if I see an average of more than 45% traffic over 5 minutes, increase the instance count by 1, cool down for a few minutes, so give it another few minutes before we go through this cycle again, and then I can increase it again. And then when I back off, when I go the other way, I'm a lot less aggressive. And really, this sort of strategy is erring more towards having more infrastructure than I need rather than less, because I want to Let's try that again. I wanted to be able to support the traffic. So when you look at the back off strategy, I'm saying, hey, look, I've now got to get below 25%, and it's got to be below 25% for 15 minutes. And then I'm going to decrease the count by 1, and then I'm going to give it another half an hour before I apply this strategy again. So it was like, let's just have more and more instances than what we need just to make sure I can deal with the traffic. Now, in theory, this is good. And in practice, it has been pretty good. Certainly, if you consider I guess, kind of the logical progression of going from dedicated infrastructure running on-prem where you had physical hardware to going to virtual machines to then going to this next step along the paradigm of cloud, which is to go to PaaS. This worked really good. But what it meant is stuff like this. Now, this is from only a couple of weeks ago. You can see the date down the bottom, which says it's the 31st of August. And this is an email I got because traffic started ramping up. And you'll see here, it says, look, my default server farm has gone from capacity with 1 unit to a capacity of 2. And then you'll notice also, check the times, because this is the interesting bit. So the time was 9:13 a.m. And then I got another one. Now this is 9:17 a.m. So 4 minutes later, it's gone, hey, we got you another one. You know, like your average CPU utilization was still over 45%. You need more cloud. So what happens then is we go from 9:17 now up to 9:21. 4 minutes later, add more cloud again. And then it happens again for a last time. So I went from 4 up until 5. So now I'm running with 5 logical instances, and they've scaled out in the space of, what's that in total, about 12 minutes. And this sounds really good. And what actually happens is as we go along, all we do is we just keep adding cost. Because what I'm doing here is I'm using an S3 instance of an Azure App Service. It costs 40 cents an hour. So when I added that first instance, I started paying 40 cents an hour extra. And then the second one came along, and it's another 40 cents, and so on and so forth. And this is sort of the beauty of commoditization, where it's like, look, you can have as much cloud as you want, and then you just pay for the bits that you have. Now, what ended up happening here is I had this sudden influx of traffic, and then inevitably the influx of traffic disappeared. So we start going back the other way. And I'm getting all of these alert emails. So each one of these screen caps here is actually an email. So it comes back and says, all right, look, we're going to take away an instance, take away another instance. Notice, actually, if I go back one, the time here, 9:56 in the morning, the next one is now 9:27, because my cooldown period is so much longer, because I'm really, really trying hard to make sure that I don't back off too quickly. So 10:27, 10:58, which of course is about half an hour later, backs off another one, and then backs off another one. So in your mind, and you'll actually see a graph of this in a moment, but in your mind, picture sort of adding more and more on top of each other and then starting to take them away. And of course, as we take them away, then the money comes back off. And I start saving myself 40 cents an hour. Now, one of the things I really got excited about when I started building Have I Been Pwned on Azure, incidentally, because I'm from Australia, we say Azure. You guys all know what I mean, if you're not from Australia. And I will not change my Australian ways. So what sort of got me very excited about Azure when I started building out Have I Been Pwned 5 years ago was this commoditization value proposition. So that the whole idea of let's just go and add cloud and we'll only pay for cloud we use, and then it backs off and everything is awesome. Now, as I said earlier, this was awesome compared to the old way of doing things, but let me show you what was actually happening with my CPU utilization when this scale up and then scale down happened. So I'm going to pull a graph here, and the graph we're seeing here is straight out of the Azure portal, report on CPU utilization. And you can see here the way that utilization ramps up really quickly and then ramps back down. And this is just a sudden influx of traffic. It could have been someone hammering the API. It could have been some sudden popularity of the service. I'm going to give you an example of how that happens later on. Now let's compare that to the instances of the app service used. So this is what my instances graph looks like. And this is effectively the graphical representation of the emails we just saw. So it scales up from 1 all the way up to 5 very quickly, and then it starts backing off again. Now, as I mentioned, these are all instances. So these are logical instances costing 40 cents each for this S3 app service instance. But there's a really interesting pattern here that I want to try and point out. If we draw a line vertically down here at sort of the peak of the CPU utilization, everything on the left of the line is not enough cloud. So I really didn't have enough cloud there. I had to keep adding instances in order to deal for the load. And even though this load sort of ramped up, you can see it sort of it goes from just about nothing up to very, very high. I had to keep adding instances to deal with it. And the reason I had to keep adding instances is that CPU utilization started to increase beyond my comfort level. But then you look at the other side of it as well, and you go, well, that utilization actually disappears very quickly. By about 726 there on the timeline, it's coming way, way down. So really on the right-hand side, I've got too much cloud. So I'm always sort of dealing with this situation of not having enough cloud, and that means I'm going to be dealing with traffic problems or rather performance problems. Or I'm having too much cloud, and that means I'm going to be paying money that I don't need to pay. Now, I'll give you a really good example of just how difficult this made things. And I'm going to start with this guy. So this, I didn't know who this guy was originally, but this guy is a guy called Martin Lewis, and he runs a show called the Martin Lewis Money Show in the UK. And in November 2016, the show reached out to me and they said, look, we're going to put Have I Been Pwned on this show, and we have a habit of crashing websites. And I'm like, I got cloud, man. Like I'll just keep adding cloud and you won't crash me, no problems. I got autoscale. And when the show was on, it was, I remember actually, I was sitting in my kitchen. It was early in the day for me because they're in the UK, they're on the other side of the world. And I'm looking at my my Google Analytics, and I'm seeing something like 200 people on the site. And I see a little uptick, like a couple of dozen extra people. And I'm like, well, that wasn't a really big deal then, was it? And then suddenly I go from 200 people to over 12,000. And this happened in the space of seconds. It was less than a minute. It was really, really super fast. Now, this causes interesting problems because if you recall, the whole premise of autoscale on Azure was let's keep adding instances as the traffic starts to ramp up. Now, this is what my traffic looked like. So when you look at that blue CPU graph, it went from like nothing to 100% really, really, really fast. Now, think about what that means in terms of adding instances. Can you add enough instances fast enough to deal with traffic that changes that quickly? And the short answer is no, I couldn't. So this is what my HTTP request looked like. I lost about 33,000 requests. So I got absolutely smashed. Now, incidentally, one of the challenges here with this particular type of traffic is that when Have I Been Pwned ends up on a TV program, you get all of these people sitting around in the UK, and it turns out it's actually a very popular show. And they obviously see the program and they see the Have I Been Pwned address pop up on the screen, and 20, 30, 40, 100,000, however many British people all pick up their phone at once. And everyone puts the address in at the same time. So this is not a nice organic flow of traffic. This made my life very, very hard. So let's move on from there and start talking about serverless, because serverless actually starts to solve the underlying problem that I kept running into with PaaS. And there's sort of a nice way of picturing what that underlying problem is, and it's called the Goldilocks principle. And the Goldilocks principle is about having just the right amount. So not too little, not too much, just right, not too hot, not too cold. You all know the story. So what we really want to do with architecture in general is try and get that balance right, because if you remember before, I always had either not enough and I was losing traffic, or I had too much and I was paying for things I didn't need to pay for. So that brings me to a demo. I'm actually going to pull a browser over and give you a little bit of a demo of how this works. And I want to talk about a service within Have I Been Pwned called Pwned Passwords. So I'm going to pop Have I Been Pwned up on the screen over here. And Pwned passwords is a feature that I added originally in August last year, and then it's gone through a few little additions. And if you go up to the passwords link, and everyone can play along with this if you want, there's a password field here. So you can plug a password in here, and it will go into the database, and it will see if that password has been exposed before. So for example, I'll pick something that's going to be absolutely terrible, go through, submit that, and it says, hey, this password has been seen 49,938 times. Now, when you do this search, it's hitting an Azure function. And I'm going to talk about functions in a moment, but I want to talk briefly about the mechanics of how this search works. Because on the surface of it, it looks like you've literally just handed your password over to some arbitrary third party. So if I pop open the Dev Tools, and I'll plug this in a little bit here, we'll clear those errors. I don't know what they are. Let's imagine they weren't there, and I'll look at them later. Go to the Network tab, and I'm going to run a search here. Now, what you'll notice here is that when we look at this request, the path that's been requested, and it is a GET request, it's not sending anything in the body, the path that's been requested is just these 5 characters. The password I entered was password with a capital P and an @ symbol, so the hackers don't know what it is. And incidentally, they do. They've worked that out. And a 0 instead of an O. It's just character substitution. The way this works is you put in the password, and then client side, what happens is the password gets hashed. It gets SHA-1 hashed. The first 5 characters of the SHA-1 hash are then taken, and that's the first 5 characters you can see in the path here, and it gets passed over to the service. The service, in its response, if I scroll this down a little bit, comes back with all the suffixes of SHA-1 hashes of passwords that are in the system. Now, if I scroll to the bottom here, what you're going to see is there's somewhere just under 497 different SHA-1 password hashes that begin with the first 5 characters of the hash that I searched for. Now, this model is called K-anonymity, so it means providing just a little piece of information to the service, not enough to identify what it actually is, and then the service comes back and then says, hey, I've got all of these things that may match the thing that you looked for. You can now compare your whole thing to one of these results. And what we're seeing here is the end of a SHA-1 hash, so this is the suffix. We already know the prefix, we sent that in the request. And after that is how many times that password has been seen before. And somewhere in this result set here, there's going to be one number which is very large, which is the one that I just searched for. So I wanted to just make that clear. So you're not actually sending me any passwords. Now, of course, you need to trust the web app because you are entering it into the web app. But a lot of people hit this API. So a really good example is EVE Online. So the multiplayer game, EVE Online, they hit this API tens of thousands of times a day to make sure that when their subscribers are actually logging into the system, they're not using a password that's been seen before, because that could put them at risk of account takeover. So this is really awesomely cool. There's about 5 million requests a day to this service. And now I want to jump back to the slides for a moment and just talk about the mechanics of how this actually runs and why it makes sense to run it on Azure Functions. So here's a good little example. This graph in some ways is a little bit similar to the graphs we saw before with PAS, where there's a sudden influx of traffic. So this is function execution counts. It's literally just how many times the service has been requested. And the obvious pattern here is that it's very flat at a very, very low amount, and then suddenly it just gets absolutely smashed. And we go from probably like 20 requests or something per unit of time here up to 1,400 requests. Yeah, almost instantaneously over the space of a few minutes. And then it backs off again really, really, really quickly. So what we're going to do here is we're going to talk about how this differs from PAS in terms of the advantage it gives me in running the service. So this is one metric we're going to look at, the execution count. So how many times it's run. This next graph is a different one. Now, if that sort of went a little bit faster in the transition than what the bandwidth allows, this is actually a different graph. Now, this is execution units. And execution units are really interesting because they're a different way of measuring the effort the infrastructure has to invest in order to service the request. So execution units are measured in an amount of memory over a period of time. This particular graph, you'll see there's 1.14 billion down the bottom left-hand corner. And incidentally, every time I see something expressed in billions and it's something that's going to hit my wallet, I do have a bit of a heart and mouth moment. but let's talk about what this actually translates through into dollar terms. This is 1.14 billion megabyte seconds. Megabyte milliseconds, actually. 1.4 billion megabyte milliseconds. So this is how much memory has been used over how long in order to service those requests. It's going to look very similar to the execution count, the previous graph, because there's a pretty constant amount of resources used for every single call of the request. Now, whether I've got a very small amount of requests or a very large amount of requests, that graph is going to roughly match the one that we saw on the previous screen. So we'll talk about pricing, because this is where the function side of things gets kind of interesting. So functions get priced based on two metrics, and one of those metrics is execution counts. So on that first graph, I had nearly 67,000 execution counts. You pay 20 cents for every million of them. So I had to pay 6 cents in order to support almost 67,000 requests. I am quite happy with 6 cents. That's not a difficult discussion that I then have to have with my wife. The other metric, of course, is the one I just mentioned, which is the function execution units. Now, I consumed 1.14 billion megabyte milliseconds, but you pay based on gigabyte seconds. And you pay a very, very, very small fraction of a cent per every gigabyte second. Bottom line is, I end up also, on top of the 6 cents, having to pay 8 cents for the gigabyte seconds function execution units. And incidentally, every cost I show here is going to be in USD because it's just the one that's most broadly understood across the globe. So in total, that cost me 14 cents. I had to shell out 14 cents to do 67,000 requests. Now, the beautiful thing about this is that this is pay per execution. This is all it is. So we've suddenly moved away from this premise of you have this great big logical unit, which is an Azure app service, and you might be using a very small amount of it, and then as you start using more of it, you might need to get another big logical unit. And now what you're doing is you're just paying for when you execute code. And this is great because you get an enormous amount of linear scale without it slowing down or without you having too much. Now, to be clear too, this is the consumption model of Azure Functions. So everything I'm talking about here is consumption model. I think that is the most awesome model because that is literally pay per use. Now, what's even cooler about this is that there are free grants. So I don't have to delve into my pocket for the 14 cents because you get 1 million free executions per month of an Azure function. Now, that roughly speaking is what, probably about 15 times more than what I actually needed. You also get 400,000 gigabyte seconds per month, which is roughly about 400 times, a little bit less than 400 times more than what I needed. The point I'm trying to make here is you will be amazed at how much you can get for free out of Azure Functions because those free grants cover you for a huge amount, and everyone gets free grants as well. I don't get anything special. This is literally what everyone gets. And then if you go over it, well, then the cost is extremely low. So for the Pwned password service in Have I Been Pwned, it's run on this from day one, and that's kept that cost massively, massively, massively low because of the way functions work. It would cost me a huge amount more if I was to put this on the old model of PAS. Now, let me move on because I want to talk about a couple of other things too. And I am keeping an eye on that Twitch comment or chat stream there as well. So if you do have questions, you can let me know over there. I want to talk about data storage because data storage is kind of an interesting one insofar as many people have very traditional views of data storage. And here's what I mean by that. I used to work in a very large corporate environment, and the view there was always, if you're going to store data, you're going to need a SQL database. Right? And many of you have probably seen this before. Like it's almost like in people's minds, the only way you get to store data in an enterprise is with a massive relational database management system. And there are times when that makes a lot of sense. SQL is very good for a lot of things, but it's also overkill for a lot of things as well. So very early on in Have I Been Pwned, I decided to do everything in table storage. So when you search through those 5.x billion records at the moment, you're searching Azure table storage. That's very cheap to run, and it really scales beautifully. Now, I also decided to use table storage for pwned passwords, and I'm going to show you what that looks like. Now, what you're seeing here is partition keys, which are the first 5 characters of the SHA-1 hash. So remember I showed you how you search by the first 5 characters of the SHA-1 hash. And in this case, we just started alphabetically, so we've obviously started with the zeros. And then the row keys are the suffix, and then you get a timestamp. Every Azure table storage instance has timestamps. And I've added a count. So for example, the third row, whatever password it is behind that hash, has been seen 630 times. And then when I was running table storage and I have a look at it in App Insights, this is what my function execution looks like. So what we're seeing here is a record of how many times over this period of time the function execution has occurred. So this is over the period of a day. You can see there's 403,000 requests, average of 122 milliseconds on top of table storage. Now that was pretty good, I think. Searching through 500 million odd records for only 122 milliseconds is probably not too bad. But I do like to optimize all the things. So one of the things I started looking at is how can I get that 122 milliseconds way down? Like, can I do a better job than what I was doing in table storage? And again, just to sort of clarify a little bit here, we are searching for these first 5 characters of a SHA-1 hash. The petition was using those first 5 characters. So when you did a search, all I had to do is just pull the entire petition. So logically, it worked pretty well. Now, I had decided to give blob storage a go. So I thought, what would it look like if instead of having all of these rows in table storage, what would happen if I put things in blob storage? And what I'd do then is I'd just create blobs like this. So this is effectively the same data from the previous screen, but now what I've done is I've just created a blob. I've called it the first 5 characters of the SHA-1 hash.txt, and then I've just put all the data directly in that blob. Now remember, on that previous slide, the function execution time was 122 milliseconds. Here's what happened when I went to blob storage. Went down to 54 milliseconds. So I sliced more than 50% of the execution time off by putting this large amount of data into flat files that sit on the file system. And sometimes I talk to people about this and it blows their minds because they're like, but you're not meant to do that. Like it's meant to be in some queryable kind of structure. Well, it doesn't matter because the nature of this data, and this is a very specific sort of data, but the nature of it is I create this great big collection of data and then it sits there and it doesn't change for a long period of time. And by shaving off more than 50% of the execution time, think back to what that does to the cost of Azure Functions. For the function execution component of the pricing, the cost reduces by more than half. It doesn't change the total number of executions, but it changes the duration with which the execution needs to occur, and that has a direct impact on cost. So that's all I wanted to talk about on storage, and I just kind of wanted to make the point here that there are ways of optimizing spend which are very different to what people would be used to in the past. And particularly when you're paying for the number of executions and how hard the execution works over a period of time, suddenly you get to save a lot of money if you can make things go faster. Okay, so I'm just going to pause here for a second because I saw a question come up here on the Twitch window. Actually, Javier or Jeff, are there any questions that I've missed that I should cover at the moment? Suddenly you get to save a lot of money if you can make things go faster. Okay, so I'm just going to pause here for a second because I saw a question come up here on the Twitch window. Actually, Javier. Sweet, okay. Let's move on because I'm conscious of time and I've got more slides. And incidentally, I actually designed this talk so that I would have more slides than time, with the hope that people would ask me questions anyway. And I'd just do like the most important stuff first. Which brings me to this next one, because this is a really, really cool thing. And this has made an enormous difference to the way I run the service. And it's the best way to make Azure go fast. Now, I'm probably going to make Javier and Jeff fall off their chairs when I show this next bit, but I reckon the best way to make Azure go fast is not to hit Azure. Now, I want to explain what I mean by this because this makes a huge amount of sense. And I'm going to talk a little bit about Cloudflare. So Cloudflare is a service which runs in 152 points around the world. So every single purple dot that you see on this map is a Cloudflare edge node. Now, just to give a little bit more background on Cloudflare, firstly, there is actually a nice Microsoft synergy here. Microsoft has actually provided funding to Cloudflare, so they have some faith in the company. They've put money into them, and Cloudflare is a reverse proxy. So what that means is that when we think about something like Have I Been Pwned, which sits over here in the West US data center, and then we think about me sitting down here in Australia, when I make a request to Have I Been Pwned, I don't necessarily need to get that traffic going all the way to the Have I Been Pwned service. I can get that traffic to go firstly to Cloudflare's edge node, and then they may respond from there without even hitting Azure. And you'll see in a moment how that makes sense. Just before I go on and actually talk about the mechanics of using things like cache, I wanted to touch very briefly on this next slide because I thought this was kind of interesting. This is a future plan for Cloudflare. And their CEO, Matthew Prince, shared this recently, and he said they're going to build Cloudflare out to 250 cities and get within less than 10 milliseconds of 99% of the global population. Now, keep this in mind as I progress, because what we're going to say here, or what we're going to see here, is that if 99% of your audience is within 10 milliseconds of what can ultimately be a cache of your data, suddenly some really, really, really cool stuff can happen. Last sort of background slide on Cloudflare first. They serve a lot of data. This is 258 billion encrypted requests over a 24-hour period. And I had to Google it, but actually that is a quarter of a quadrillion. So there are a quarter of a quadrillion requests that they're serving in a 24-hour period. So they have a massive global scope. Now let's sort of get to the pointy end and talk about what this means when you run a service through Cloudflare. So this is a graph of pwned passwords. And I wrote a blog post recently about how to make pwned passwords and serverless and stuff go very, very fast. And this was in the post. And what you're seeing here is a graph over a period of 1 week. Now, if you look at the top left-hand figure, there are 32.4 million requests in the last week. The next figure is the cool one. 32.2 million requests were cached. And what that actually means is there's a 99.62% cache hit ratio. So 99.62% of requests could go to one of those little purple dot edge nodes around the world and have a result returned directly from cache rather than hitting the origin server. So what we're sort of saying here, and I'm not saying cache, I can see that comment there. It's cache. I will hold my Australianism all the way through this. You guys know what I mean. So what we're really seeing here is a massive reduction in the amount of traffic that has to go to Azure. And that translates to a massive reduction in the bill, and it translates to a massive increase in performance. So think about Matthew's tweet just before as well, getting 99% of the population within 10 milliseconds of a Cloudflare edge node. What would that do to your performance? That does awesome things. Now, I was kind of curious as well, that 99.62%, like this is really, really good, but how do I get like the last 0.38%, or somewhere very, very close to there? And I noticed there's like this one tiny, tiny little bit of the graph here. You see how there's like a little bit of light blue? For some reason, my cache hit rate, cache, I can't stop thinking about that. My ratio dropped in that little bit of slice of time. So they may have had a higher than usual cache eviction ratio, for example. So that did cause it to drop a little bit lower than what it could be. But I also don't want to diminish the significance of how important it is to have functions behind this, because sometimes things like this happen. So I snapped this only a few days ago, and we can see for the first part of this graph, it's like dark blue all the way, and it's like, all right, this is awesome. I'm just getting massive cache hit ratio. And then for some reason, like just after 9 a.m., I guess, around this point in the graph, cache was purged or something like that, and everything I had in cache disappeared. And then suddenly I've got a massive uncache ratio. And you can see over time, as you get to the right of the graph, the height of that little blue line, or the light blue line rather, starts to diminish. So more stuff is getting cached. But that meant I had an absolute sudden ginormous increase in traffic to that origin website. Now think back to the Martin Lewis Money Show thing, where when I got sudden influxes of traffic on PAS, it actually caused some real problems. I either didn't have enough resources or I was paying too much money. This is what it looked like on my Azure functions when it hit. So have a look at that bottom left line to begin with. We're there at about 50 requests per unit at a time, and then suddenly we go to 10,000. So the question we're sort of asking here is, if we use a strategy like this, does the underlying infrastructure, does the origin service have the capacity to suddenly have a 200-fold increase in traffic in what might be single or low double-digit seconds rather? So almost like instantaneous maxing out of the traffic. There's also a couple little spikes in there as well, and I think those green spikes were for some reason degradation of the service accessing the blobs. I'm not entirely sure why that happened. It doesn't correspond with traffic. It's something on the back end, but it's very transitional as well, very transient rather. Now, of course, if you serve from cache and there is this sort of transient outage where your origin request times go up, well, then you get a lot of isolation from that because a lot of stuff's just coming from the edge anyway. So this is sort of the point I was making around making Azure go fast by not hitting Azure, but also having the ability to have like this instantaneous scale up if you do suddenly get an influx of traffic. And to be clear as well, the Cloudflare service you can get into for free. So a lot of what I'm showing here won't cost a cent if you lay that on top. And then, of course, you save on function execution units and execution counts. Okay, so I want to go into something just a little bit different here, which is about rolling over. Because one of the things that I started to do, and this is really only in very recent weeks now, is, as I was mentioning before, I was getting excited. Like I was going, hey, these functions are really, really cool. They solve a bunch of problems. It was only Pwned passwords, which was running on functions. So just to sort of put that back into context, if I bring my browser window open, this was hitting an Azure function, and I get all the awesomeness we just spoke about. The front page was hitting Web API running in the web app itself. And what that meant was that this front page was going to have all the same sorts of performance problems as what I was writing about earlier on with things like the Martin Lewis Money Show. Now, what happens if you want to roll over? So part of the challenge that I had is that when someone hits the API on Have I Been Pwned, this is a public API designed for people to consume. And just in case you're curious about doing this, if you go to API and you go to Overview, you'll see a whole bunch of info here about how to go through and consume it. Getting all breaches for an account, for example. And you'll see that there's a URL here, haveibeenpwned.com, yada, 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 yada. Now that maps directly through to the app service, to Web API running in Azure. If I want to roll this over to a function, that's going to run on a different host name on a different service. So how am I going to do that? So continuing the serverless all the things paradigm, I wanted to go from Web API at that path to functions at that path. How are we going to do it? So there's this really, really cool concept called a Cloudflare worker. And Cloudflare worker is serverless code, just like Azure functions are. And pro tip, serverless does use servers. It's just that you never have any visibility to them. But it's serverless code on the edge. So that means every one of those 152 data centers around the world runs your code. I added code that looks like this. And I'm just going to explain this very briefly. This listens to incoming requests. It gets the requested URL. It lowercases it because I don't want this to be case sensitive. It looks for the old URL, haveibeenpwned.com/blah blah, and it replaces it with the new URL of the function. And what it does then is the Cloudflare worker from the edge calls into that new location. And the joy of this is you can roll over to Azure functions without actually having to do anything to the original app. All you're doing is saying, hey, when the request comes in through Cloudflare, pick it up, send it to somewhere different, and then obviously I return a response which still adheres to the same contract that's in the API, so it's still the same JSON structure and still the same response codes. But now what I can do is I can just roll over in one clean swoop without having to change anything on the actual Have I Been Pwned end. So I think I've actually managed to time that like bang on 45 minutes. We may only have seconds left. Are there any questions that people have about any of this? And Javier and Jeff, I'm throwing that question about questions to you. 45 minutes. We may only have seconds left. Are there any questions that people have about any of this? And Javier and Jeff, I'm throwing that question about questions to you. What are the main concerns about serverless? You know, to be honest, and one of the things that took me a while was the rollover process. And part of the concern about the rollover process was I had dependencies on old paths, which is, you know, basically, if I go back one slide, this is the answer to it. Incidentally, if you go to my blog and you look for Azure, there's a tag for Azure, you'll see that I have written before about rolling over and doing things like A/B testing. You can use workers like this on Cloudflare to do things like say, let's just take 20% of my traffic and send it to the new path. Because if I can take just 20% of the traffic, then that's fantastic. Now I can sort of, you know, basically use some guinea pigs without breaking it on everyone. The other concern that comes to mind is that functions are pay per execution and they scale beautifully insofar as it's just entirely linear. You just keep loading on traffic, and under that consumption model, you just get given more servers in the serverless model, you know, like underlying instances of servers. The one thing that admittedly keeps me up at night sometimes is what happens if I just suddenly get like massive unexpected traffic, and then I look at my bill and it's crazy. And honest, I've had heart and mouth moments, particularly when you see function execution units expressed in billions or even trillions. So I do have a concern about that. The mitigation is you can configure alerts in Azure. So you can say, hey, I would like to get an alert so that if I start seeing more than N requests over a period of time, let me know about it. And that doesn't necessarily solve the problem, but now you can have the discussion about, is this traffic worth paying for, or is this traffic I now need to take some sort of mitigation against? All right, so I am conscious of time. Were there any other questions? I see someone here who says not a question, but a thank you. Thank you. That's awesome. That's nice to hear. Jeff, Javier, anything else? All right, so I am conscious of time. Were there any other questions? Good question. Would you like a book? Thank you. That's awesome. Silence. All right, so hey, while it's not that we're sort of killing time per se, but if you go to my blog, let me find you the things that are actually worth reading on this. So this blog post here, which you'll see on the front page if you scroll down a bit, serverless to the max, doing big things for small dollars. That talks in a lot more detail about the things that I just showed you guys. So that's definitely worth a look. I've got a heap of numbers in there as well, and it's a typically long blog post that I tend to write. If you look at the Azure tag as well, this one on seamless A/B testing talks about what I just mentioned before. It's like, look, let's just take 20% of my traffic, for example. Another thing that I show in there as well, this is a really neat way of doing it. I did a Cloudflare worker that said, if the request contains a particular cookie, then send it to the new API, the one running on functions, otherwise send it to the old one. And what this allowed me to do is just go and set a cookie in my own browser. So it's like, let's just test all my own requests, and I'll start sort of dog fooding it, sending my traffic and seeing how it goes. And then probably the last one there to mention as well is the I Want to Go Fast blog post. So this talks about why I rolled over from table storage to blob storage. And it effectively talks about the nature of the data and the cost savings by reducing that execution time from 122 milliseconds down to, I think it was about 54 or something. But look, there's a heap of other stuff on the Azure tag, and if you scroll far enough back through it, you'll see all the logic that went into using PAS and autoscale. There's a blog post in there that has a lot more detail about how I got smashed by that Martin Lewis thing as well. So maybe a cautionary tale in there. And if anyone else has sort of any other questions as well after this, you can find me on the Twitter as Troy Hunt. Is there anything else, Javier and Jeff, from your side, guys? And if anyone else has sort of any other questions as well after this, you can find me on the Twitter as Troy Hunt. Is there anything else, Javier and Jeff, from your side, guys? Yep. Okay, so There are multiple ways of answering this. Now, let me show you first of all, like the formal, officially Cloudflare way. They have a pricing tab there. If you go under pricing, you can see the options. The $0 per month one is actually really interesting. And the reason why it's interesting is there's a huge amount of stuff you can do with that. So one of the things that the people keep asking me is they're like, look, you wrote about Pwned passwords, etc. Cloudflare does give me some services for free to support the project. How much would it actually cost? Because you're talking about this massively high cache hit ratio. What I'm trying to do with Cloudflare is run other services through there on the free plan. So for example, whynohttps.com. There's a project that I'm running with Scott Helm to track the world's largest websites that aren't using HTTPS. This website has a 99 point something % cache hit ratio. This runs on the free plan. So this doesn't cost me or anyone else who runs through on a service like this anything. It's totally free. And that is a 99 point something % cache hit ratio. So you can do a huge amount of this for free. The blog post about serverless to the max does specifically talk about what happens if Cloudflare wasn't there, what would the cost be? And it's still really good because Azure functions are really cost effective to run. And then it says, okay, well, what would happen if I wasn't getting some freebies from Cloudflare and I had to use either their normal mainstream free service or pay for it? And it's still a ridiculously small amount to support about 5 million requests to that API per day. And keep in mind, every one of those 5 million requests is searching through 517 million records as well. So the scales are pretty cool. And it's still a ridiculously small amount to support about 5 million requests to that API per day. And keep in mind, every one of those 5 million requests is searching through. All righty. Well, hey, thank you very much, everyone, for joining. If you have questions, please grab me on Twitter and check out troyhunt.com on that Azure tag for heaps of other cool stuff.